Welcome everybody, and I'm at a very excited place and talking to an exciting person today. We got Nicolas Spethmann right here, and maybe you can first introduce who you are and also why we are here, because there's something super interesting just next to us here.
Yeah, absolutely. So my name is Nicolas Spethmann, as you said. I'm heading what we call Quantum Technology Competence Center at PTB, Germany's National Metrology Institute. And what we do is we develop metrology for emerging quantum industry. And one example you see right behind me here, this is for ion traps that are a core technology for clocks and for quantum computing devices. And what we develop here is characterization methodology and characterization technology for ion traps from industry and also from research.
Yeah, so this is technologically at the frontier of what we can do. I believe this is quantum technology, but there's also a link to industry that actually want to go and use that technology, and that links up to your lab. Can you say something about that?
Yes, absolutely. I mean, nowadays there's a lot of stuff going on in quantum technology. So there are companies starting out to develop quantum computing devices and also other devices. And one core technology are ion traps. And we now have companies in Europe and also worldwide that develop and fabricate ion traps themselves. So this means there's a market starting up. And this is also our interest to develop characterization technologies and techniques to characterize those devices for a market. So that's the connection to the market.
So you're working here even using commercial products that are supposed to be commercial. I think you even have some here.
Yes,
are you correct?
There are some here. So here's one little chip. So what you see here is an ion trap on this chip that goes into this machine. So this is a small chip where you have a charged atom. So this is basically an atom. You take an electron away, and then the atom is hovering in this little structure here. You cool it by lasers to very low temperatures, and this gives you the full control over the quantum states. And this is basically the technology you need for quantum technologies, for instance, quantum computers and clocks. And indeed, we have commercial ion traps here that are characterized. We also have other types of ion traps. I have to be a bit more careful with this one. It's a bit bigger. Also for academia, it's a very important thing to do. And indeed, it's cutting-edge research also.
Amazing technology. Hello back, and as you can see, we just have been switching buildings laboratory very quickly because we're in the middle of an ongoing experiment with ion trap just a second ago, so we didn't further want to bother. And we have a lot of laboratories to choose from here, because here in Braunschweig, metrology is a lot of stuff going on. I think even one of the most precise clocks of the entire world is being right here on your campus.
Yeah, there's quite some number of modern atomic clocks running at PTB's campus here in Braunschweig, correct.
Exactly, and everybody is kind of syncing or calibrating to the clocks here in the whole of Europe. Which actually brings to want to talk about standards. What is the link to standards here? So let me ask you, quantum technology, quantum computers, where's the link to standards?
Yeah, so quantum technology is a very modern and broad field. So we have different domains or pillars, if you want, of a whole field, which is quantum computing, quantum information science, quantum communication, and also quantum sensing and quantum metrology, as we do a lot of here at PTB. So the link to standardization is that this is a very new field, and one of the questions is, how do we actually characterize and compare technologies and figure out what this technology is capable of? So this is one of the things that's very relevant for us, and for this you need a common ground to compare and how you even talk about this technology, and this is where standardization, for instance, comes into play.
Yeah, but you also talked about a lot of different application areas. Some are still experimental, very early. Some might be later in their We talk about things like qubits, I think, on supercompute. Are we too early or maybe already late in some of these technologies?
Yeah, that's actually a question we discussed also in the standardization committees quite a lot, and also when we interact with people from industry. And I think the answer here is it depends, because as I said, quantum technology is quite a broad field. We do have technologies that are pretty much into the future. And then it's still important to think about, okay, it is too early and we just look at it and try to figure out when it will be important. But there are certainly things that are important right now. One thing is terminology. So if we talk about qubits, if we talk about something I want to characterize, what are the numbers I need and how do I measure them? And I need a recipe for this that ideally is done the same way by everyone. So those would be examples. Terminology, characterization is early on. Some other technologies are further out. And I would also say we also have fields like quantum communication where there are already products on the market. And then it's obvious, I think, you need common ground.
Yeah. So even already mature products, I understand, huh? As you are saying.
Yes. I mean, it's at least something where a market starts to grow. That's, I think, fair to say.
Yeah. Now we got standardization in all types of different things. A lot of people will think about relatively simple standard, maybe the size of a piece of paper, A4, or the size of a sea container going on a ship. Mm-hmm. But here we're talking about cutting edge type of technology on the frontier of what we know in science even. What makes standardization different there, or do you think it's a rather similar process in which you approach that?
Mm-hmm. Well, first of all, I'm a scientist and I'm now working in standardization for quite some years, so I certainly have a certain way of experience that I'm not sure how general this is, but I would say in quantum technology you certainly have this close connection to research, and this will be there for the time to come. So that's also certain, and this probably also has consequences for how standardization works. But it is different from like traditional standardization that's out there for some time, which, and this is important for me to say, is also very important. It's just a different beast because we have this close connection to research.
So research-based standardization, if we want to call it that way.
Well, I would say it also has a role for research, because even in research papers, if you define what you measure, it might be important. Usually you don't have standards there, but it goes into this direction, I would say.
So standards are made in standard setting organizations, and what standard setting organizations then are active or important if we talk about quantum technologies?
Well, yes, you're right. For this we have standardization organizations in national level, on European level and worldwide. So from my point of view, obviously we're in Germany, so I'm working with DIN and also with DKE, the German standardization organizations. But we do a lot of stuff on a European level. I'm also the co-chair of CEN-CENELEC Standardization Committee, so-called JTC 22 on quantum technology, which is trying to cover actually all the fields we talked about before. And right now on ISO-IEC level, there actually is a new committee called JTC 3 that is basically also trying to address the whole of quantum technology. So this is happening now on international level.
And so when you say ISO IEC, that is the global level, right?
This is
above Europe, that's the whole world participating.
Exactly. So
colleagues from other regions.
Exactly. So ISO IEC is the global level. So you have countries from Asia, Europe, the US, and the Americas. And in Europe, obviously, you have the European countries. And I think it's also, you now might wonder, is it really necessary to have all those stages? Sometimes maybe it's not. But I think from a European point of view, it's very important that in quantum technologies, we had this committee already quite some years ago, and we had some time already to coordinate in Europe. And I think this is very useful now, because now it's happening on ISO IEC, and we can take some of this coordination and talk with one voice in some sense.
With one voice, and perhaps also have a bit of a head start, having already...
Yeah, I mean, in some things, I think we have a head start, but, and that's very important for us, we don't want only European standards, obviously. I mean, anything we do should be something that's applicable worldwide in the end, but obviously it should reflect what the technology in Europe is doing.
Yeah. And since you're personally participating in standardization and being the co-chair, I understand, of GTC 22. Can you tell a little bit about the process? You have chairs, I think, co-chairs, participants, maybe other roles in that process. Can you shortly say a bit how that works in practice?
Well, again, I am by training a scientist originally, but so I have the chair of JTC 22. He has a lot of experience in standardization. So Oscar van Deventer from the Netherlands, actually. And so we basically, in this case for JTC 22, we are a bit complementary by design. So I'm the quantum scientist and also with some experience in standardization by now, but he's a professional in standardization. And this is how we try to do this. And yeah, as complete as possible, fill out this role of setting up JTC 22 and getting it up and running to create standards for the future. And we also have working groups in JTC 22 on the different fields we talked about, so communication, sensing, metrology, and computing, with different conveners from different countries. And also one strategy advisory group that's actually where I myself am the convener also.
And what is a convener?
Yeah, the convener is the person who is in some sense leading this working group, but you also ask who is taking part and what we always try to do and what's the foundation of standardization. It should be participation from industry, from academia, also a bit from policymakers, and you should have all those interest groups represented as broadly as possible. And the convener has the job of managing the work group and getting people to work. I mean, that's what we want. We want to get results out of the working groups in the end. So
how many people in the end are active within GTC 22?
Oh,
not exactly, but are we 10? Are we 50? Are we...
Okay, so how do you define active? So we do have, I think it's more than in the hundreds of experts that are actually involved in some way in JTC 22. But obviously not all of them are writing on documents, but in the working groups it's like a subsection of them. And one should also say that this is on a European level, so we have national mirror committees. And then in each mirror committees, you have people that are not actually coming into the European committee. So it's many people, I think, and it's growing strongly.
Good. It's super fascinating topic, I think. Is there any last message that you want to share with our viewers here?
Well, we talked about the connection to science and to research. And for us, quantum technology is something that's on the verge of being commercially relevant and going into the market. So what we would like to have is more industry participation as much as possible. And this is what I would also say as a message: come join us and just look into what's happening, and if you can, join and participate.
Very well. Thanks so much, Nicolas, for
was
talking
a pleasure
to me today. Thanks.